Talking about my tab project. It's known as ballistic forensics. Ballistic forensics is exactly what it sounds like, analyzing projectiles, specifically bullets for this project, using forensic technology. Ballistics evidence is vital in many criminal cases to track down perpetrators. Being that we live in a country that has over 200 million guns, you can obviously understand why technology in the field of ballistics is important. I'll start by giving you a little background on the information just to get some keywords and different stuff about ballistics, and then I'll start to describe the technologies, and I hope you enjoy. What does actually mean? I'm sure you all heard the term before in Law and Order or CSI. According to Wikipedia, ballistics is the science of mechanics that deals with flight, behavior, and the effects of projectiles, especially bullets, gravity bombs, rockets, or the like. Simply put, ballistics involves understanding what happens to a bullet from start to finish. For this project, we will only focus on bullets and technology used in analyzing them. Ballistic fingerprints are an important word in the ballistic forensics field. Ballistic fingerprints are unique and identifying marks on bullets and cartridges that can be analyzed and traced back to the original origin. These marks made on the bullets and cartridges are almost as unique as one's fingerprints, hence the name. No two guns will ever make the exact same mark on bullets or cartridges. This is one of the prime reasons ballistic investigators can track and analyze bullets. A gun will also always make the same mark on a bullet. The first bullet and the 1000th bullet will both have the exact same fingerprints. This makes it possible for firearm examiners, if they gain possession of a gun, to shoot test bullets out of it and compare them to the actual bullets under investigation to determine if this is indeed the gun that was used. This is actually how they caught the DC sniper back in the early 2000s. So you're probably wondering what type of fingerprints are on bullets and cartridges. Striation marks are one form. This is an example of a striation mark. Right here, you can see the lines on the side of the bullet. They are unique to every gun. They're also known as chamber marks. Chamber marks are the marks that bullets encounter while traveling through the chamber. There's also extractor marks, which are marks made on the cartridge while it is being ejected from the gun. There are firing pin impressions that make a specific mark on the back of a cartridge. This, for example, if you look in the middle there, it's a very distinctive design that only one gun will make. There are many other types of marks, but you can see how all these different features make bullets unique and analyzable. There are many identifying marks investigators use as well. The pathway of the bullet throughout the air, how it hits a target, whether it shatters or stays intact when hitting a target, are all different types of fingerprints that can help investigators solve cases. There gave you a little insight into the background of what ballistic investigators look for when dealing with forensic ballistics. All this information on bullets and fingerprints is good, but it's the technology available to investigators that makes it possible to solve crimes and analyze bullets. There are several technologies that investigators use in the field of forensics. The first device, and it's probably one of the most important devices when it comes to analyzing fingerprints on the actual bullets, is known as the comparison macroscope. Notice the key word here is macroscope. It's different from a microscope because normal microscopes have objective lenses of 100 times and higher. A macroscope generally has objectives of 5, 10, 20, 30, and 40 times magnification. A comparison microscope also has two scopes for two specimens attached to one tube. This way the examiner can look through one scope and see two different bullet casings side by side. When they do this, examiners are looking for fingerprints. This is an example of what a comparison microscope would look like. You see there's the one eye hole and then the two different specimens. Used by ballistics investigators is known as computer tomographic angiography, or we'll just call it CT for short. Similar to an MRI, except the CT can produce 2D and 3D images of scanned body parts. While CT is mainly used in the medical world, it does serve for ballistic investigators. It is normally used to help radiologists and doctors get a better, more detailed pictures of the inside of trauma patients. It allows them to assess the amount of damage to the body and get more accurate readings. For forensic investigators, it can allow the examiner to find the original trajectory of the bullet, as well as where fragments are in cases where the bullet shattered. This is a non-invasive technique which allows the investigator to analyze bullet fragments that may be altered or unreliable if removed by hand. Small bullets such as .22 calibers would be in this category. This is an example of a picture that would come up on a computer tomographic angiography. You could see it's not the best picture in the world, but you could see how it's got a 3D image, how it's got the spine, it's got the different veins, the body parts, it's the neck. It just shows you all the different things, and this is how ballistic investigators can track bullets without actually going inside the body. Technology that's used by ballistic investigators are known as body models. Everybody's seen a body model before on TV. They're the big gel guys that people shoot bullets at. They're used by forensic examiners to get a better understanding of why and how a bullet acted the way it did, as well as to get a better, more accurate analysis of the bullet when it penetrated the body. The compound is made of glycerin soap and ordnance gelatin. These two compounds together make body models that most resemble the human body and its tissues. Examiners can then run experiments on the models and compare them to real victims and see if something stands out of place that they can use to connect to a crime or maybe even solve a crime. And all the marks and striations and fingerprints are tracked down. One of the most important pieces of technology to help draw conclusions and bring everything together is known as IBIS, also known as the Integrated Ballistics Identification System. IBIS is a national database ran by the FBI and ATF that keeps a history of bullets and cartridges. It basically maintains a computerized database of digital ballistic images of bullets and casings from crime guns, allowing for matching and comparison. In 2000, IBIS technology became NIBIN, the National Integrated Ballistics Identification System, and unified federal, state, and local law enforcement gun crime evidence into one system. This allowed investigators to enter data for one bullet and compare it to other cases nationwide to help reopen cold cases or assist other investigators across the country. In the past, before the database, the only way for investigators to compare bullets to other crime scenes was off sheer memory. So an investigator would actually have to look at a bullet, and if it looks similar to a case that he remembered 20 years back, he would go and look at it and then have to go through all the files and try and track down that bullet. So you could see how the process was tiresome, long, and pretty much not reliable. A study conducted by Anthony Braga and Glenn Pierce in 2009 investigated the use of IBIS by the Boston Police Department. And the study found that in 1990 there were 10 cold cases that were linked to newer cases through ballistics forensics. Only 10 cases a year, basically, from then on, after 1990. In 2002, the first year IBIS was implemented in the Boston Police Department, the average number of case hits shot up to 68. So 10 before IBIS, 68 with IBIS. In 2009, the year the study was conducted, the Boston PD had entered 2,400 bullets, 13,000 cartridges into the image database, and has recorded 400 matches in 2009 alone at the time of the study. That's a huge difference from 10 in 1990 to 400 up a year ago. That ballistic investigators are trying to initiate is known as microstamping. Currently, California is the only state in the nation that forces companies to use microstamping techniques. Microstamping basically imprints a specific serial code and number onto bullets and cartridges. It is nearly impossible to remove, and when a user goes to buy bullets, his name becomes associated with those serial numbers. This is an example of microstamping. If you see in the middle there, there's a little serial number, so that would be linked to the user who bought the bullets. This basically allows investigators to track down those who commit gun crimes using the registered bullets. All the bullets made in California undergo this process now. Obviously, you can see there are many flukes with this, such as the actual owner of the bullets and gun may not have actually fired the bullet. Police officers' guns are exempt from microstamping, which could, increase corruption. You can do the math on that. The law only applies to California also, so if someone really wanted to commit a crime, they could just go to Nevada or Washington and buy bullets and come back to California. Though it has its flukes, it's a step in the right direction and can help reduce illegal gun trading across states and speed up investigative processes. States right now that currently have pending legislation to initiate microstamping are New York, Connecticut, Rhode Island, Massachusetts, Maryland, Wisconsin, and Illinois. So that's all I got for you on forensic ballistics. I hope you enjoyed what you saw, and have a good night.